Good morning, it's a new day, and I'm refreshed, well slept, coffeeed up, and ready to do a little machining today. And where I left off yesterday in this machine shop build was, you will recall that I located and drilled this pin into the flywheel, and this is for the reversing mechanism. So that part is done other than cutting the pin off to length. So I'm over at the milling machine now, and I do have my rotary table mounted on the machine, and it's centered such that the center of the spindle lines up perfectly with the center of the rotary table. And I did that off camera, and I zeroed out my digital readout. And what I'm going to do now is taking this brass eccentric, I'm going to make that semicircular groove in there, and that will be located 200 thousandths off center. And you'll remember this little washer that I had, and that is 200 thousandths off center. And I have mounted in the collet a tiny 1/8 inch end mill. Of course, 1/8 inch isn't tiny, it's relative. 1/8 inch is 1/8 inch. I guess I shouldn't use the word tiny, but I'm arguing semantics with myself. Now I'm going to mount the eccentric in this teeny tiny, well-loved 3-jaw chuck. I interrupt this video for a trivia question. Who is this great man? And the only clue I'm going to give you is that he is not an American, he is not a forefather of our country, and the answer is more or less in this item down here, but of course you're not going to be able to see that in this video. But who is this man and what did he do? And I will divulge the information, the answer, in a later part of the video. The groove is going to be offset by 200 thousandths, that's from the center, and it's going to be 150 thousandths deep with that 1/8 inch end mill. So right now I'm watching the digital readout, and I am moving it 200 thousandths. And there I am, and I'm locking the table in the x-axis. And that is the location of the groove. This will be a bit of a plunge cut into that soft brass, but nevertheless it's going to work all right. I've done this before. And once I do that, and I won't take this all in one cut as far as the depth is concerned, just about 15 or 20 thousandths at a time, and then I will slowly rotate the table. Watch down here, I've started at 0 until I get to 180 degrees. That's halfway around. Well, in fact, I need to go a little bit farther than the 180, and I talked about that earlier. I did a little math on that, and to add the diameter of that pin, which is well, about 75 or 80 thousandths, that needs to be translated into degrees. And doing the math, I came up with approximately 200 degrees, but I'm just going to go 190 excuse me, and see what I get. So I'll back this up to 0, and here I go. I'm zeroing out the dial on the knee crank, so I have a reference to how far I'm going, because I've touched off. Now I'm raising the table now as I'm rotating the table. And now I'll go back to 0, backing up, now that I've established the depth of cut. And now I'm going to go clear around to 190 degrees. Now this 1/8 inch slot is considerably wider than what I need for that tiny pin, but the reason I'm doing that is if you get into end mills that are much smaller in diameter than 1/8 inch, they're very delicate. So that's 80 degrees, 90. $150, 180, and there I am at 190. Sometimes I use a straw to blow it off. And boy, that groove seems a lot wider than what I need. And now I'm increasing the depth of cut. Now going back to 190 for my starting point. And now I'm cranking it the other direction all the way to 0. $30, $20, $10, and I'm back to 0. I've taken several passes off camera, and now I'm down to a depth of 150 and continuing to cut. I've got a little bit of a close-up here, so I hope you can see it a little better. Now it's important to keep the chips out of there on a deep cut so you don't keep recutting them and grinding them. And I'm not using any type of lubricant because this brass is so soft, but it might have helped a little bit, I don't know. I'm feeding relatively slow. Although I'm using a rotary table, an index head, dividing head set up at 90 degrees in the vertical position would serve this quite well. I'm at 100 degrees. $130. $150, and of course I'm watching the graduated dial at all times as I'm doing this. $170. $180. And there I am at 190. This is my final pass, and my depth of cut is only 10 thousandths. I started at the 0, and I'm going to crank right around to 190 degrees, and I'm moving a little faster simply because the depth of cut is so small, and this is my final pass for a total of 200 thousandths deep. 60 degrees. 80, and I believe you can see the protractor in this view. This is not a real sensitive operation. That is, I cannot feel the cutting taking place because of the gear train on this rotary table. There's 170. I'm just about done. And there's 190. Now let's take it out and have a look. I do not have a chuck key for this, so I have to use just a little square and a adjustable wrench. There it is. I'll deburr it, and you can see that that's really quite a bit wider slot than what I need. Let's go over to the bench. Looking at it from this view, and I do have to trim quite a bit off of this pin, but there's the flywheel, and now here's the newly finished eccentric, deburred. Now when I install that on the shaft with the slot going into the pin, you can see now that I can turn it and it stops. I can turn it and it stops about 180 degrees. Stop, stop. And that is going to change the timing such that I can run the engine in clockwise direction and then rotate this and it will run counterclockwise. Now there's way too much space in here, but yet I don't want it so short such that the eccentric is all the way up against the flywheel, although that probably wouldn't hurt anything. But I'm going to take off, and I do not want the pin to bottom and cause a little binding that way. It needs to be a little bit off of the bottom. In other words, about like that. So I will trim about 1/8 of an inch off of the pin, and then I'm going to make just a little bit of a sleeve here using the hobby brush to space it out. I'm going to trim this pin to length. Now I wouldn't use snips, clippers, even if this wasn't hardened, but remember that was a drill bit, so I like to use my little Ryobi or Dremel, and I've got a bunch of them with a little abrasive cutoff wheel, and wearing safety glasses, just trimming off like this. And that doesn't leave much of a burr either. Okie doke, I'm ready for a semi-final assembly here. And as I do this, first of all, notice I had to use a little fiber, a red fiber washer right here to get my spacing so that the eccentric strap is pretty much parallel with the casting. I perhaps trimmed just a little too much off of this aluminum boss here. But that's the beauty of those little spacing washers. So I've got one of those in there, and I've got that 3/4 inch diameter fender washer there. Remember that the eccentric has to spin freely, and it has no set screw in it, so make sure that it can spin freely. It will be driven by the flywheel, remember that? So let's get her installed here. Now I cut off a piece of this hobby brass, and that's 7/32 OD, which makes it 3/16 ID. You know, it's pretty hard to handle these real small pieces, but I guess I managed. So on it goes as a spacer, and the purpose of that, again, is so that the pin doesn't bottom into that eccentric groove. And now as I slide this on, see how it turns one way? freewheels, then goes the other way. And then I will lock it with this set screw, and again, that is what drives the eccentric, just the opposite as that other engine. Okay, I'm going to time it off camera because that takes a few moments of patience to do. And when I get it running, I'll get her back on. Okay, it's ready to rip. It's all been adjusted and set so the timing is just right. And let me just say something about the wagon wheel effect. So sometimes when you look at this or some of my machinery, you might think it's running backwards, but I'm going to run it clockwise first, regardless of what it might look like to you. But that's the stroboscopic effect, and I think most of you guys that understand that, you watched Harold Edgerton's films about the strobes and so on. It's most interesting. But anyway, I'm going to start it clockwise, and the pressure is 3 pounds. I can slow it down here by putting my thumb over the exhaust. Now watch how I reverse it. I simply stop it, and now it's going the other way, irregardless of what it looks like. And there is no such word as irregardless. I did that on purpose to see if you'd catch me. It's regardless, not irregardless. We can stop it. Now it's running in the other direction, so we have a instant reversing without any lever or without any Stevenson complicated mechanism. Let's see if she slows down just a little bit here. It doesn't take much pressure to run these. That's about 1.5 pounds of pressure. Now I am going to run this on steam, so don't leave yet. There it is the other direction. I am going to run it on steam. Now the reason that I allowed so much shaft, excess shaft here, is I do plan on putting a little pulley on there. I might have to make a pulley, and running a little generator, and I hope to do that on screen here with steam rather than air. After all, this is a steam engine. But I have several other things to do. I'm not done. I wanted to do some cleanup work, and I wanted to put a bevel on here, or a chamfer rather, that will look something like this. I don't know if it's an improvement or if I'm doing a bad thing, but I'm going to put it on the mill, and I'm going to take some material off like that, and maybe a little bit off of the valve side too. And then I intend to make that base, or that plinth, yet. And I will do that on camera. So now that I got this running, tubalcain is a happy camper. There it goes in the other direction. Now let me show you where, or what it is that inspired me to do this reversing mechanism, although it's not much of a mechanism. I've shown this little engine many times in my videos, and my brother gave it to me, and it came from a flea market. I believe it to be a Wagon engine, Wagon. And originally I am deducing that this was mounted directly on a boiler. This was a boy's toy. Directly onto a boiler, but that was long gone, so I just have the engine itself, and I mounted it on the board. I was going to make a base. I may still make a base out of aluminum, but I have to make a pattern, but not in the mood right now. But a couple things are unique about this engine. First of all, it's headless. Secondly, it's made out of lead. This entire red casting is lead, as is the flywheel. So simplicity is what it's all about in these boys' toys, I suppose, so they could make them super cheap and make them affordable for a dad to buy for his son for Christmas. And I think this is probably 1920s or 1930s vintage. But what I wanted to show you on this is the reversing mechanism, and it's similar but not identical to what I did, but they have removed material. Actually, it was cast that way. Can you see the difference here in thickness from here to here? And if I can roll that around to the other side, there's the other end of it, and there is a little pin. There's the back end of the pin. I'm not sure if you can see the other end. There's the other end of the pin. So when we turn it this way, it's catching on that part of the lead flywheel. Turn it the other way, changes the timing, and it will go the other way. So that's what inspired me, and possibly doing it the way that they've done here could be done easier than what I did with a larger end mill and less chance of breaking the end mill. And by the way, remember I said that I made that 190 degrees, and I wasn't totally sure what that should have been. I knew that 180 wasn't enough because I had to take in consideration the diameter of the pin, but the 190 degrees turned out just perfect. Okay, now on to making the plinth. While I was running this little engine with the lead flywheel a few minutes ago, I think many of you noticed I have a wobble in the wheel. And I don't know what caused that, but that is one of my lead flywheels, and these are somewhat delicate and they can bend in the spokes if they're misused or dropped or whatnot. So I don't know what I did to it, but I need to make another batch of these small flywheels. I showed how to make the larger ones in another video, but it's just like pouring sinkers. But I have to wait for summer, and then I'll make up another dozen of them or so, so I have them in stock, because this is the last one that I have. Here's how I'm going to make the plinth. And I just laid the engine on there and allowed a 1/2 inch approximately on each side. Got it marked. This is 3/8 aluminum. And I want to cut this off because there's a screw in there. This is used, of course, so that'll be waste stock there. So over to the bandsaw I go. Here I am at the bandsaw. Now when you use a bandsaw, make sure that you keep the blade guide down very close to the work so you have a minimum amount of a blade exposed. And I like to use a wooden block at all times to push. It makes it easier on your fingers, and it keeps your fingers out of the line of fire. Sometimes I put a little kerosene on there too when I'm cutting aluminum. Seems to keep the blade from loading up, because this is not a skip tooth blade. And that didn't take long, but you can hear the thumping where there are teeth missing from the blade. I'm squaring up all 4 edges, and this is the 4th side, 4th end. Then I'll put some corners on it. I'm milling a cove edge on the plinth, just like this, using a 1/4 inch diameter ball end mill. Little bit of kerosene on there, and I happen to grab a pretty dull cutter, so I'm taking this in several passes. But notice now I've already done the far end. that I've got this butted up against a stop such that all four sides will be the same depth. And here it is, the last pass on the long side, the fourth side. Well, that's just about enough for today. The first thing in the morning, the job I'll tackle is mounting the engine onto the plinth. Then I'll strip the whole thing down and chamfer these corners, and it's almost ready to run under steam. So thanks for watching, and that's it for today.